So in this video, I'm going to be talking about the readings for this week, plus a little bit of extra content from Bala that I promised to get to from last week. Okay, so this week we're reading a couple chapters from Stephen Chapin's book, The Scientific Revolution. This, I think, is probably more accessible than the Bala reading, so this is written specifically as an introduction, which is nice. I think Chapin's an amazingly clear and accessible writer. Still, there's more of it than you're used to, so I'm going to say that if you read pages 1 to 8 and pages 15 to 37, that's plenty. There's some interesting stuff in the rest of it, particularly if you're interested in history and historiography, but those are the only parts that I'll consider sort of testable. Okay, so Chapin starts out this book with the following sentence. There was no such thing as the scientific revolution, and this is a book about it. Okay, so witty, right? So he's starting off with the distinction that Bala makes earlier, which is between revolution and no revolution accounts of history. And obviously Chapin is situating himself with the no revolution account. And what that means is he doesn't see a very radical break between pre-scientific revolution and post-scientific revolution thinking. He sees it more as a certainly change, but a kind of relatively continuous and gradual change rather than a sharp break. He's also, if you recall the other distinction that Bala made about ways of telling the history of science, he's also talking a little bit in this chapter about internalism and externalism. So Chapin says, historians in recent years have become dissatisfied with the traditional manner of treating ideas as though they floated freely in conceptual space. So treating ideas as though they float freely in conceptual space is a way of talking about internalist histories of science. That is, just one idea leading to another idea. So the externalist picture is one that includes things like the people, politics, culture, material realities, all kind of interacting to shape the history of ideas. And so he's at minimum going to do a little bit of both. So he's going to talk about the ideas, but also about how society helps to shape ideas. So this is Chapin sort of situating himself in the discussion, what kind of history of science he's going to do. But for our purposes, I think one of the most interesting things that he talks about in this chapter is the ideas. So, and specifically the idea of mechanism. Okay, so this is the philosophy of the scientific revolution, if you please. It's an understanding of how nature works, which sort of sets the rules for what's reasonable in terms of investigating the natural world. So in the chapter for this week, Chapin contrasts it with what came before it, which is broadly the Aristotelian view. So what I propose to do now is to take you back and talk a little bit about Aristotle's picture of the world so you can see the contrast between it and mechanism. And a little later in this video, I'm going to contrast it with what Bala calls organic materialism, which is yet another way of thinking about nature that we see in China. Okay, so stepping back to Aristotle. Now, here's the Aristotelian universe. If you recall, he's got this theory about the kind of proper places of things in the universe. So the proper place of Earth, one of the four elements, the four earthly elements, is in the middle. The proper place of Earth is in the middle. So a rock is mostly made up of Earth with maybe a little bit of the other elements mixed in. But because it's mostly Earth, anytime you throw a rock up, it'll fall back down. It's trying to get back to its home, to where it belongs in the cosmos. When you push air underwater, it bubbles back up because the proper place of air is above the water. That kind of thing. So you can see how the world is segmented into sort of proper places. Now, of course, our world is a mixture of all these elements. The four elements are all mixed up and kind of confused. So it's not these pure layers, but everything in Aristotle's physics is tending towards its place in the universe. So, and there's no, to recall, there's no math in Aristotle's physics. He's just describing how the essence of various elements determines how objects mostly made up of those elements behave. Okay, so Aristotle's physics is teleological. So when you're trying to explain your own behavior, you often cite your own goals, right? What you're trying to do. So if something gets in the way of what you're trying to do, you go around it. You find some way of adapting. So the specifics of how you actually get to your goal can vary widely, but the goal itself often stays fixed, which means the goal is very often the best explanation of why you behaved the way you did. Why did you do this rather than that? Well, I was trying to get to that goal. That's what we mean by a teleological explanation. It's kind of goal-based explanation. And it works really well when you're dealing with intelligent agents. It can work well when you're dealing with the larger set of living things. So most living things, you can understand and explain them using teleological explanations. Aristotle thinks that kind of the whole universe can be understood teleologically. Now, he's not necessarily attributing minds to everything. There's kind of a debate about how much mind there is in his teleological explanations, but he's certainly allowing goal-based explanations, like the rock is trying to get back to the center of the universe, in his physics. Okay, so, and he kind of gets made fun of in the scientific revolution for thinking this. So this comes to be seen, teleological explanations come to be seen as a kind of non-explanation. So here's Thomas Hobbes, as quoted in Chapin. Hobbes says the following: "But if you ask what they being the Aristotelians, mean by heaviness, they will define it to be the endeavor to go to the center of the earth, so that the cause why things sink downwards is an endeavor to be below, which is as much to say that bodies descend or ascend because they do." So Hobbes is accusing Aristotle of giving us basically circular explanations that say it does what it does because it does it. And I mean, I think it's hard to argue that we weren't better off getting rid of teleological explanations like, why do rocks fall? So Chapin argues that in the scientific revolution, the metaphor of nature as a kind of mechanism, and especially the clock metaphor, becomes really important. So, we build clocks, we build them with a purpose in mind. So in some sense, a clock has a goal, but you don't have to explain it by citing its goals. So the teleological explanation is a kind of extra add-on that maybe we want to apply. But if you wanted to, you could explain the whole behavior of the clock just in terms of its mechanisms. That is, just in terms of its parts, their shape, their density, and their interaction. So this gear moves and it causes this gear to move. So it's a parts-based explanation, and it's an explanation entirely in terms of pushing and pulling of the parts on each other. So to understand a clock, you can understand it purely mechanically with no goals being invoked. And that's what's supposed to be so nice about the clock metaphor, is that we get a really nice, clear explanation without the apparent circularity of this Aristotelian teleology. So this is the argument for a mechanistic picture of the world in the scientific revolution that gets us clearer explanations. Okay, so, I mean, we saw earlier that there's clocks all over the world. There's lots of ways of keeping time. Here's a picture of a water clock. And, these are used all over the place. But when we're talking about clocks as mechanisms, you don't want to miss out on understanding that the Chinese clocks that were being built before the scientific revolution are head and shoulders above other clocks. So Bala points out in the last chapter that some really impressive inventions are being imported into Europe just before or during the scientific revolution. And one of them was, coming through the Mongolian Empire, very sophisticated mechanical clocks, sometimes using water as their power source, sometimes using sand, but the mechanisms inside them are mind-blowingly complex for the time. So Bala's argument is that these clocks, these mechanisms, are part of what shapes the European imagination, so that they were so impressed with the sophistication of these things that it becomes possible to imagine all of nature on the metaphor of a clock. Okay, so just to give you some details on what these clocks were like. So here's Susong's clock. So Susong lived from 1020 to 1101 CE. This thing was finished in something like 1094. It stands between 30 and 40 feet tall, so really large. At the top, so the purpose of this thing is not just to keep time. At the top, you can see a little circular thing, and that's a model of the sky. And this clock keeps that model of the sky rotating at the same speed as the sky itself. So it's in sync with the sky. In the middle, there's a little model of the Earth, which is also rotating. The final version had some, and I'll just quote Wikipedia here. So some mechanically timed and rotating mannequins dressed in little miniature Chinese clothes that exited miniature opening doors to announce the time of day by presenting designated reading plaques, ringing bells and gongs, or beating drums. These cute little mannequins come out of the clock at designated times. Okay, so this thing is a marvel of mechanical engineering. It actually gets captured by some of the Mongolian emperors and disassembled, and they bring it back to their capital, but they can never quite figure out how to put it back together again. So after it's captured, it never really works again. But this is supposed to be an example of the kind of incredibly sophisticated mechanisms that are being built in China during this time. And this and a variety of other things are being imported into Europe and really sparking people's imagination, making them think it's possible to imagine all of nature in a metaphorical way as mechanism. Another bit of the kind of Susong's clock that was really impressive was a chain drive. So if you've ridden a bicycle, you're familiar with a chain drive. So he's got one of the first recorded continuous chain drives where little gears move a chain. One gear moves a chain and the chain moves another gear. So just to give you a flavor of what kind of mechanisms we're talking about. Okay, so these and a bunch of other mechanisms, I won't go into any great depth. You can look it up yourself if you're curious, but these and a bunch of other mechanisms were coming through the Mongolian Empire into Europe during the period preceding and during the Scientific Revolution. And Bala suggests that these very impressive mechanisms convince Europeans of the power of the mechanical metaphor, and even taking it beyond being a metaphor, literally thinking of nature as a kind of mechanism. And that's a radical break from the Aristotelian picture of the world, which sees nature as kind of alive in some sense, or at least goal-driven, whereas mechanisms are just pushing and pulling. Okay, so let's contrast that. So we've got the Aristotelian picture, we've got the European picture of mechanistic materialism, you might say. Let's contrast that with one more picture of nature, which is the Chinese one, which is Charles Needham gives it the name organic materialism. So the Chinese are materialists. They certainly don't believe that things like, in other cultures believe things like there's mind in nature. Aristotle is sort of arguably one of these mind in nature people. There's other people who believe this in a more robust way. So the Advaita Vedanta school in Hinduism believe that the world is literally made of mind, made of spirit, something like that. The Chinese, generally speaking, don't believe this. They believe that the world is a material place governed by material forces. But they don't think it acts like a mechanism. They have a kind of organic materialism. So just to give you an example of this kind of philosophy, there's a bunch of different versions of this, but one example comes from the Neo-Confucians, who say that everything has li, L-I, li. It's a kind of principle. But it's a principle that, so li can literally mean something like the grain of wood or the fibers in muscle. So li is a pattern. It's a pattern inherent in nature, but it's not a simple symmetrical pattern. So when you look at wood grain, it's a very complex pattern. It can be asymmetrical, but you can see that there's a pattern there, right? It's clearly not just random, but it is complex and it's hard to reduce down to a simple law or formula. Whereas in Europe, the kind of mechanistic materialism, they're going to be big believers in simple laws and formulas. Okay, so Li is the kind of pattern of things, and organic materialism is the idea that the world has a pattern, but it's an organic pattern. Chinese natural philosophers, scientists, if you will, place a lot of emphasis on the dense interconnectedness of things. So hierarchies of densely interconnected, constantly interacting parts that are better thought of in terms of processes than fixed objects. So if you take a chunk out of a clock, like you pull out one of the gears, it's just a gear, right? Like it's going to sit there being a gear for until it rusts. It's going to be there for a long time. It doesn't depend for its identity on the other gears in the clock. You can take a gear out of one clock and plug it into another. But if you take out like one of my kidneys, it doesn't stay a kidney for very long, doesn't it? It becomes a smelly pile of mush pretty fast, right? So the identity and cohesion of my kidney depends crucially on all of the other parts of my body. So all of my biological parts are densely interconnected, and their identity is constituted by an ongoing process rather than the intrinsic properties of their parts. So that's kind of organic materialism. It's a view of nature that sees it as profoundly interconnected in deeply complex ways, not really easily reducible to simple laws and formulas. Okay, so sometimes people have put the blame, as it were, on organic materialism for why modern science doesn't develop in China, because of the unwillingness. So if you see the world in those terms, you're going to be kind of unwilling to reduce it to simple laws and formulas, the way modern scientists try to do. But Charles Needham suggests that actually the philosophy of organic materialism is pretty good for some of the discoveries that come out of China. So for example, one of the really monumental discoveries, the world-changing discoveries that shapes the way people navigate for the rest of history, is the compass. And the compass actually fits beautifully with organic materialism. So a compass literally works because there's an invisible field permeating all things that connects with everything, that connects everything to everything else. And if you've got a piece of magnetized metal, it will be sort of moved by this invisible force. So a field theory is a really nice, so a field is a kind of set of interconnected parts, and those interconnected parts move the magnet. So Charles Needham suggests organic materialism is perfect for coming up with the magnet. Another thing that organic materialism is pretty good for is coming up with the theory that the moon causes the tides. So again, distantly related things are in an interconnected relationship. You might not necessarily be able to see the relationship, but detecting it is perfectly in line with the philosophy of organic materialism. Whereas if you recall the mechanistic picture of things, you really want to see how things can be pushing and pulling on each other. You really want to see their mechanical interaction. So Chinese thinkers had, by like the 1st century CE, put it together that the moon causes the tides. This is, again, Charles Needham suggests, a perfect example of organic materialism in action. Okay, so Chinese thinkers are not the only ones who put this together. Other people had suggested it, but it really does fit very nicely with their philosophy of nature. Okay, so compare organic materialism with mechanistic materialism, which is the philosophy of the scientific revolution in Europe. Here in mechanistic materialism, we're really only going to focus on local interactions. We're going to focus on the properties of the individual parts and how they interact on a very local level. So the goal is to come up with strict universal laws or rules that govern how one part of the system interacts with another. And notice again how beautifully a clock satisfies this desire, this picture of how things in the general work, right? You can understand how each individual part influences, independently of all the other parts, whatever it's touching. You can explain those interactions in terms of purely local pushing and pulling. And once you've done that, you understand how the overall thing works. So I hope it's clear why the clock is a brilliant metaphor for mechanical materialism. The kind of historical irony is it was invented by, the clock is not invented, but the kind of really sophisticated mechanical clocks that so inspired the Europeans to take up mechanistic materialism were invented by people who believed in something more like organic materialism, which shows that while a philosophy can enable and inspire and make you think something's important, it's not necessarily sort of a limiting factor. So you can certainly understand how a clock works within the philosophy of organic materialism. Okay. And just to finish this off, I think it's interesting to note where we are in modern science. So modern science is, at long last, after several centuries of being kind of mechanistic, has at long last come back around to dealing with complex systems of many parts interacting in complex ways. It's the computer that made this possible, really. So running enormous multivariable simulations is what has led us to deal with complex systems using the techniques of modern science. But it might be interesting to think that we're, in some sense, coming back around to some aspects of organic materialism. Okay, thanks.